Welcome to Unit 5B, video for skill number 49. I can solve quadratic equations using the quadratic formula and classify roots by using the discriminant. We'll begin our notes on page 49A and title it Quadratic Formula. In addition to factoring and completing the square, we can use the quadratic formula to solve quadratic equations. In factoring, we learned that if we had a problem such as this, x squared minus 10x equals negative 24, what we could do is move all pieces over to the left-hand side and set the whole equation equal to 0. From there, we would factor the equation, and we could use factor fish or factor box and cross, whichever method you prefer. In this particular instance, we get the factored form is x minus 4 times x minus 6. Finally, the final step to solve it is we apply the zero product property. So either the x minus 4 is equal to 0 or the x minus 6 is equal to 0, which means in the end x is either 4 or x is 6. If I wanted to use completing the square to solve the same problem, we see that it's already in the form where the x terms are on the left-hand side of the equation and the non-x, or the constant, is on the right-hand side of the equation. So the first step in completing the square is to take half of your b value, so half of negative 10 is negative 5. And negative 5 squared is positive 25. So we took half of b and added it to the left-hand side, and we'd wind up adding it to the right-hand side as well to keep the equation balanced. From there we can simplify the left-hand side of the equation to x minus 5 squared, and the right-hand side becomes 1. If we square root both sides, we get x minus 5 equals plus and minus 1. And then finally we add 5 to both sides, giving us x equals 5 plus or minus 1, which means either x equals 6 or x equals 4, which is the same thing that we had found when we did the factored form. The problem is that the factoring version only works on some quadratic formulas, some quadratic equations. Not all quadratic equations can be easily factored. And then the completing the square version can get into some pretty nasty fractions that aren't fun to deal with. So a third method was developed called the quadratic formula to remedy those two problems. And in fact, the greatness of the quadratic formula is it always works. It will work every single quadratic equation you're given, and it's relatively easy to carry out once you know the formula. To carry out the quadratic formula, what we need to do is have the equation in standard form. And as you can see right now, our equation is not in standard form because the constant is on the right-hand side of the equation. So if we were to rewrite this into standard form, we'd have x squared minus 10x plus 24 equals 0. The key to carrying out the quadratic formula is identifying the variables, the coefficients in front of the variables. So what we have here is, in standard form, it's ax squared plus bx plus c. So in our example equation, our a value is equal to 1 because there's an implied 1 in front of the x. Our b value is equal to negative 10. And our c value is equal to positive 24. The quadratic formula allows us to solve the equation for x. What x for this equation gives us an answer of 0? And the quadratic formula says x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So what we're going to do is we're going to plug in our values. Negative b, since b is equal to negative 10, we're going to have negative 10 plus or minus the square root of negative 10 squared minus 4 times 1 times 24, and this is all over the value of 2 times 1, 2a. If we were to simplify this equation, we wind up getting 10 plus or minus the square root of 100 minus 4 times 24 is 96 all over 2, which is equal to 10 plus or minus root 4 all over 2. Simplifying that further, we get 10 plus or minus 2 over 2, which is equal to either 12 over 2 or 8 over 2, which means our answers are 6 or 4. You can see that the answers 6 and 4 matched with our two other versions where we used factoring and completing the square to solve it. The final piece of the lesson is this term discriminant, and the discriminant is actually the number that is contained underneath the square root, b squared minus 4ac. In our case, for this particular problem, that was 4. I'm going to do one more example and then I'll talk about what the discriminant can tell us. On page 49b, I worked through two more examples. The first, we were given the equation 3x squared minus 15x plus 2, and we're asked to find the zeros. The first task we need to do is identify a, b, and c. So a is the number in front of x squared, a equals 3. B is the number in front of the x, so negative 15 is b. And then c is the constant, so 2 is the constant. If we plug those three numbers into our quadratic formula, we get negative 15 plus or minus the square root of negative 15 squared minus 4 times 3 times 2, and that whole value is over 2a. In the second step here, I simplified down some of the pieces, giving me 15 plus or minus root 225 minus 24, and that is divided by 6. The final step that I arrived at was 15 plus or minus root 201 divided by 6. Now the root 201, if we go all the way back to skill 5, the square root skills, or maybe that was 3, we could try to reduce the square root of 201. However, in this particular case, 201 cannot be reduced, so it's left as is. If we wanted to, we could write this as 15/6 plus or minus root 201 over 6, and the 6 is outside the radical. And then we could reduce the 15/6 to be 5/2 plus or minus root 201 over 6. I personally prefer it as a single fraction like this, but sometimes you will see answers displayed in a simplified form like this. I'll leave example 2 up for you to look over. As you can see in that example, the discriminant is actually a number that is a perfect square, and we are able to reduce the square root into an integer. On our last page of notes, 49C, I introduced the final type of a problem that you might encounter, and that is one where the discriminant actually winds up becoming a negative number, which brings up the possibility of complex numbers. As you remember, a complex number is a real part plus or minus an imaginary part. So in example 3, we have a discriminant that is negative. Which brings us to the final piece of what does the discriminant tell us? The discriminant, which as you might recall is b squared minus 4ac, is the piece that is underneath the square root in the quadratic formula. If b squared minus 4ac is a positive number, so if it is greater than 0, then we will have two distinct real solutions. So we might have an equation where the graph drops down below and then swings up. So our two solutions are the two real zeros. If b squared minus 4ac is equal to 0, in the second case, that means we have one real solution. So our parabola comes down and it touches the axis, and you get the one solution right where it touches the axis. And then the final condition is where b squared minus 4ac is greater than 0. And in that case, we get two distinct non-real solutions. And that's going to occur if you have a parabola that doesn't cross the axis at any point. In the examples we used, examples 1 and 2 both had two real solutions, and the example 3 on this page has two non-real solutions. I've provided the last piece down here an example that has one distinct real solution, and I'll leave it to you to use the quadratic formula to find that. And now for your viewing entertainment, I have put together a quadratic formula Dr. Seuss style poem. The Quadratic Formula, Dr. Seuss Style, by Katie Benedetto. Every Y down in Yville knows Yville's the best, for the town has a secret not shared with the rest. It's a glorious place, it's the best one around, for here all the answers to questions are found. No question exists that will stump Zimmy Fizz, the great Y-Queen who knows every answer there is. So I'll tell you one tale of an answer she gave, which for Y mathematicians caused time to be saved. A small Y brought the Queen a new problem to try. She saw it and said, with the blink of an eye,
"Never fear, young Y lad, why I'll show you a trick. I can solve this quadratic equation real quick."
Each value there was, while she renamed each one, claiming that nice names would make this more fun.
Variables, well, they're whatever we wish. So like 1, 2, red, blue, I'll call this one fish. The number of fish squared shall be called hooray, and the number of fish by themselves shall be yay. What then is left? Well, there's one more thing only. That last little constant shall be called lonely.
But how do we solve this? For which fish is this true? Well, to solve this, we now have some real work to do.
Minus yay over 2 times hooray,
She then says,
is equally close to each root that there is. And from here, the distance to each root is the same. It's the following distance, which I now claim is the product of lonely for and hooray, subtracted from yea times itself, and I'll say, take the root of this number and then you may merely divide this by 2 times hooray. With this distance, you'll see that you're nearly done. From here you will find either 2 roots or 1.
And the Y lad had left a little confused. But he then understood, and so he then mused, "Why, the Y Queen was wrong, she must be berserk." The answer she gave him did not always work. For the root of a negative, that does not exist. Was there possibly something the Y Queen had missed? And the Y Town then fell into mathematical slumber. Until the next Y lad asked about complex numbers.